Welcome back to education, everyone. I hope you had a very nice morning tea. Thank you for your patience with our non-technical difficulties. Who would have technical difficulties at a technical conference? Okay, so this is Sujatha. Sujatha is a very experienced computer science teacher, currently at Pymble Ladies College. She has previously been lead educator at Grok Academy, lecturer at University of Sydney for the Masters of Ed program. She worked with staff and students K-12 for a while now. Prior to teaching, she was a developer. So, like, all the things. She's been all the things. We're going to welcome her now to talk to us about teaching OOP using Pokemon. Thank you, Sujatha.
Thank you. Hello, everyone. Thanks for having me here. Long-time admirer of PyCon, first-time visitor and presenter, so really, really excited to be here. All right, so this talk came about because I was stuck. And like most teachers experience at some time or another, you find yourself teaching something, or at least you know it, but you really don't know how to best teach it. So this came about as a result of that. And how many of you, out of interest, have actually played Pokemon or are familiar with it? A lot of hands going up. Lovely. And this is exactly the nostalgia that I'm going to be tapping into to help us teach programming in object-oriented. All right. This is the OOP challenge. It is abstract and difficult for beginners. I know when I first learned object-oriented programming, and this is showing my age because my first programming course was, I would say, a long time ago. Much more than the age of some of our audience members today. And it was in a language called Eiffel. I'm not sure if any of you have heard of that. Eiffel is brutal, and I found it awful and hard and difficult to understand. So it's hard. There's also the cognitive load issue, learning syntax and concepts simultaneously. Now, when we teach programming, we try and do both. We do a little bit of concept, then we demonstrate the implementation. But for most students who are learning their first programming language, they can't tell the difference. They don't know the difference between a concept and its implementation in a particular framework or language. And here's the other thing. All the traditional examples out there around vehicles and shapes snore. Like, I find it boring looking at it, let alone my students. And the other part of this is a lot of the object-oriented content out there is aimed at university students. It's all very good, but it's not necessarily fit or best fit for school students. So that's where I was coming from. Now, Pokemon works, and like many good ideas that I have, I stand on the shoulder of great people. And I'm going to shout out a friend of mine, ex-colleague called Drew Eastlake, and I caught up with him earlier this year, and I was moaning to him about how am I going to teach OOP to these girls. And he said, what about Pokemon? And I went, you're a clever person. And I went away, did my homework, and ended up making an entire unit of work out of it. So Pokemon logic intuitively maps to many object-oriented concepts. So we've got classes, we've got species, we've got individual Pokemon who are objects. So having a familiar domain, and again, Jack, your talk this morning was a really good start to say that context matters, the why matters, but having something familiar to grab onto just creates a firmer footing for the students. All right, so the three things I'm going to be talking about, I'm going to start with 3 key design decisions. Any of you who have taught any student, regardless of whether it be formal or informal settings, know the number of decisions you make as educators. I'm going to be talking about just 3 of them that I had to grapple with. My intent is to do live demos, but if the technology doesn't provide, I've got all the code samples for you to have a look at. And finally, some of the strategies that I used and the things that worked, things that didn't work, things that I would change next time around. Okay, so the first decision that I had to talk about or think about was imperative or object-oriented. So Professor Michael Colling, who's a fantastic computer science educator in King's College in London, he publishes every year 8 tips for CS educators. And his number 1 tip, he always says objects first. If you want to teach programming, teach with objects first. And he's mindful that when he wrote this list a long time ago, he was only teaching undergraduate uni students. And so he understands and accepts that the context for high school is different. But he still maintains, if you want to end up with object-oriented, you should start with objects. And here's why I ignored his advice. Because here's the thing about CS Ed research. A lot of it is excellent, but we have to consider what might it look like for us now, me, my students in this classroom, right? My students have come from a very rich background, but not much programming. I am teaching a Year 11 course that is new, that hasn't necessarily been taught before in the school, and it's actually new for the state as well. I still need to tackle absolute basics, brackets, syntax, variables, and we know how hard variables can be for kids who are learning this for the first time. So I really wanted my students to have early success, so I started with imperative. I did a full term of imperative programming using Python. We built a Wordle game together, which was wonderful. We used GitHub, we did all the things, and then we got set up for approaching object-oriented programming. The next decision was, now that we are doing OOP, do we start with concrete or abstract approaches? So abstract meaning your shapes or vehicles, much more concrete meaning things like Pokemon, right? So the Pokemon approach, students immediately understand your attributes and your methods. When you start throwing language at them, and computer science, I don't know, many of us come from a CS background, some of us come from an education background, some of us are just here because we're interested in Pokemon, but there is a lot of content and language. We are blind to it. The expert blind spot is very, very real. And there is nothing like learning something new for the first time to make you realize just how much our students have to deal with when they're learning skills for the first time. So I was really mindful of that as well. We always have that balance between engagement and a theoretical foundation. I have always subscribed to the fact that I do not want to sacrifice theoretical foundation on the altar of engagement. My belief is engagement is good, but engagement cannot and should not be the priority over actual learning. So how do I get that balance correct? All right, so the thing I did was I did a bit of both, right? So perfect decision maker, I couldn't decide, I decided to do both. And my third decision was design first or code first. Now, all the purists in the room will say, of course you should design first. Why would you code? Like, we want our students to have excellent practices. We want them to go into industry and be the sort of developers or technicians that can write really solid code with design in mind. Correct, absolutely. But design first versus code first, I only have a certain amount of time to play with, and I have this little thing called the syllabus that constrains me, right? So I had to do a lot. So I decided to do, again, a little bit of both alongside. Thankfully, for my students, they've come from a background where in term one, I laid those foundations down for them. We had done extensive work with pseudocode and algorithms. They'd done data flow diagrams. So going into class diagrams and design for object-oriented was just the next step. This is what we do in computer science. All right, so a bit about my context. And again, a lot of caveats because I work in a wonderful school that is extremely well-resourced. I have a very small class, only 9 students. And this is an image of the quarter that I walk past every day. So you can, I guess to the type of environment that we have. So 9 girls in my class, and all of them, when I did a little pre-test or an interview, said they had prior knowledge in programming. And I went, great. I'm going to really push these girls, and they, in turn, are going to push me. They've come from elective data science, co-curricular robotics, but scratch the surface, the substance was not where I expected it to be. Okay? If statements were problematic for some of them, assignment statements were problematic. So I had to reevaluate and figure out where to go. Again, for context, this is our course across the 2-year period. Any of you from New South Wales teaching may be familiar with this. For non-New South Wales-based folk, this is what we're dealing with in New South Wales. Brand new software engineering course. The first year being examined is this year's HSC, and there's a lot of content. So in Year 11, we have 3 topics, and they are the foundation for the Year 12 topics. And in Year 12, this year, the students are sitting an online exam where they have to write Python code in exam conditions. It is hard. Okay, so this is what I'm preparing my students for. Okay, what are the OOP concepts I needed to catch? Now, this is just a snapshot of my syllabus dot points, but for the focus of today's presentation, I'm going to be doing a quick race through objects, classes, encapsulation, abstraction, inheritance, generalization, and polymorphism. And again, those of you who are familiar with EduSpeak will see the top little verb there, apply. So I can't just do this theoretically. The girls and my students, or any student, needs to know how to do this practically. All right, so let's get started. We started with class diagrams, and here I did draw upon the tried and tested vehicle examples because I wanted a lot of examples in class that the girls could practice. And once we practiced it with a few, we then applied it to our Pokemon example. All right, so then we created a class diagram. I also looked at CRC cards. It's a really well talked about tool for designing classes, but I abandoned it because, again, at the moment, I was just going to start with one class, see how we went, and once we started adding more, we could refine our class diagram. All right, this was the question I had in class for my students before we started. What should every Pokemon have and be able to do in our system? And one of the biggest challenges here was scope creep, right? Kids are amazing. They want to do so much, but we also have to figure out where those constraints are. And that's one of the hardest things to do as a teacher, is to quash these little beautiful minds that want to go and conquer the world. You have to say, but no, I need you to do this. All right, so that was a bit of a challenge, but we eventually got there, and we eventually came across this. We designed a really simple class diagram, but there's a lot of cognitive complexity here. We've captured the idea of variables, we've captured our data types, we've looked at attributes and methods, and by now the girls have also, they're familiar with functions, so they understand that in the OOP world, a method is just like a function, but it only applies to that class and the data in that particular object. So again, there's a lot of complexity going on. All right, so we then decided each object is unique with individual state. Each Pokemon is going to track its own health point, its own level, its known name, and its status independently. So, for example, when Pikachu takes damage, Charmander's health does not change. So we had to set some scope and set some parameters for our project. And with that said, our first code sample, and I'm not sure how we're going to, should I risk going to the code sample? Let's go for it. All right, I love that. Okay. Screen mirroring, I'm going to stop extending, and this time I'm going to choose content, window or app. Hooray! Okay, so while I'm on here, I may as well just go through all 4 code samples. So this is built for the purposes of today's demo, and all of these code samples I'll share with you at the end. But this was roughly the approach I took with my students. We'd had a lot of examples, and we talked about what the constructor does, why we need init, what does self mean, you know, and we had half a lesson on this huge metaphysical, metacognitive discussion, and oh my goodness, teaching gifted year 11 students, it's a very short journey between programming and philosophy, okay? Which was lovely, great discussion to have. We talked about things like, how do we set initial attributes? What does it mean to initialize an object? And so when I gave them scaffolded code, I followed a very clear structure. I gave them doc strings so that there was documentation. I told them very clearly what I wanted them to do. Okay? It is so easy to get overwhelmed. And, you know, I love the fact that no one in this room yet has mentioned the elephant that we all deal with in teaching programming. So I wanted to sidestep that and give my girls as much help as I could so that they wouldn't go to their good friend Claude and get Claude to do their work for them. All right? So that was one of the examples there. So that's our first little demo. And I'm going to jump back into my screen mirroring. Okay. And so once we do that, we go into, oh, we don't have that. Are we supposed to get that? Can I get some help, please? Oh, yay, okay. Look at that, I can technology. Awesome. All right, so the next one was we looked at object interactions, and this was the hardest part. We spent roughly a week and a half on this, where students had to realize that how do we actually get our Pokemon to battle each other? what is it that we need to do? And we did a whole bunch of modeling. I let the girls take over the whiteboard in my class and the class next door so that they could actually figure out the logic. But the key takeaway was that message passing is fundamental in the way objects interact with each other. So a Pokemon needs to attack, and when it gets attacked, it needs to take damage. Right, so we figured out we need two main methods, and so we designed these methods to be able to attack, pass the other Pokemon's name, and that was another really big thing. The girls were just passing in the name of the Pokemon as a string. No, you need to pass the whole object, because it's not just the name, it also has attributes, right? It's like, you going into a room, if you want to get your name marked off, it's not enough that you just take your name badge or someone else takes your name badge. The teacher needs to see the whole you, the whole person as the object for us to verify that you're there. So passing in objects took a little bit of getting used to as well. All right, so that was a code sample, and in the interest of time, I'm going to go through and then I'll jump back. The third one was encapsulation. So then we talked about, well, what are the things we should and shouldn't be able to do? It's not fair that I can just go in and modify my own Pokemon's health status and decimate another Pokemon's health status even before we've started battle, right? So it really considered cheating. I shouldn't be able to do something like this, right? So then we looked at the whole idea of private attributes, protected attributes, which was wonderful because that's really where encapsulation starts to shine. But I'm not going to badmouth Python, but there is a problem in that Python does not necessarily enforce private attributes. So this is where I have to say that the intent is what matters, right? I've taught the concept, the students know how it's implemented, and we know that as programmers, if you try to work in industry and change a protected attribute, your teammates and your colleagues are not going to be very impressed with you. So we want them to develop good habits so that if they translate over to other languages like Java that do enforce this, at least they have a really solid foundation to be able to work with that. But this example still works because students intuitively understand that I should not be able to just go in and modify attributes like that. Now, I also considered getter and setter methods, and in fact, I even wrote a lesson, and then I abandoned it, going, that is far too much right now. My students are not going to get it, and that's basically sacrificing the broader goal for some very small objectives. So I thought I'll leave that for later. Then we went into abstraction, and by now we have built enough of the project to see evidence of abstraction, right? With a single line of code, we're essentially creating a whole Pokemon object that has attributes. It knows how to fight. It knows how to take damage. It might even do other funky things if you want to put little print statements in there. So the constructor abstracts away all the work. So, and the teaching moment here is that the girls know that they don't need to know exactly how the Pokemon is built, but because once it's built and when the class is defined really, really well, it's just a matter of using it. So we're now starting to talk about the power of reuse, and where good design really shines is that once you do it well, you shouldn't have to touch it again, unless your requirements change, of course. The other example is when you do Pikachu.attack and you're passing in the opponent Pokemon as an object, it triggers, again, a whole bunch of different operations. It takes damage, calculates the health left, figures out when the Pokemon should faint, when it should be restored, all those sorts of things, right? So abstraction lets us focus on what we want, not necessarily how it happens. So again, once we design it, it's there for us to use, right? Then we went into inheritance because throughout my girls were saying, Miss, Pikachu and Charmander are not the same type of Pokemon. And I went, okay, can we please leave that till 4 weeks in? Because then we can talk about it. Right, so this is when inheritance is there. So Pikachu is an electric Pokemon and Charmander is a fire Pokemon. I have 2 children who one is well and truly an adult and the other one is almost an adult, and I had a lot of help from them navigating the work of Pokemon as I was designing these lessons. We do, rely on the knowledge of people around us. And so the next thing I did was I created some templates for them where I wrote an example of the Pokemon as a parent class, the fire Pokemon as the child class, and then they had to use that as a template to create the electric Pokemon. So there was a lot that they went through. We looked at how you can avoid code duplication. So you're using super to basically initialize and use the parents' initialization. We talked about the fact how children are so lucky. They get everything their parents have, and they can go off and do their own thing. So, and we also know children don't just exactly grow up exactly like their parents. Children will change their minds. So then we talked about overriding, right? Your parents may want you to do one thing this way, but you're going to go off and do something a different way. So we talked about how we have the parent attack method, but each type of Pokemon can have its own attack methodology and essentially demonstrate method overriding that way. And finally, we get to generalization. So all our Pokemon share common features, but with different attack methods. So there is a lot you could do. The world of Pokemon is massive, but I had roughly 6 weeks and a lot of content and skill to cover. So this is roughly where we landed. And then we talked about polymorphism as well. Again, same method name, different behaviors, and the fact that Python basically determines the attack method needed based on the data type or the class type. All right? Okay. Some of the implementation strategies, and again, huge caveat because my girls are extremely motivated. There is that, agency in the school. The culture is very much high expectations, high support. We want you to do well, and we'll do everything in our power to get you there. So I relied, and Prim is an absolute godsend. The work of Sue Sentence's team, predict, run, investigate, modify. So I had a whole bunch of self-paced exercises where they learned the skills and then they applied it to making their own Pokemon battle. So that was the framework and the structure of the entire unit of work. Scaffolding is hugely important, so I gave a lot of them partially complemented code. In fact, I even had, and again, I'm going to shout out to Linda McIver here because your Data Science Institute work where you had level 1, level 2, level 3, I've taken that on to say, all right, level 1, when you need a little bit of scaffolding, if you need a lot, go here. So again, I gave my students a choice about how much support they wanted. I gave them small groups, so I said you're going to be working in groups, and there was always that risk of under and over scaffolding, but that's something that we teachers have to deal with all the time. Over-engineering was a huge concern. I had so much to cover, and my girls wanted to do so much, but I really needed to keep bringing them down, and there's always that sense of perfectionism. We want everything to be perfect, and we want this to be so good that all our friends play it. And I had to keep saying to them, the professional games that you see out there, they're done by industry professionals with, decades, and they work in large teams, and they don't have 6 other 8-hour subjects to deal with, and they're not doing national figure skating championships 4 days a week, all right? So trying to balance all of that was hard, but we did get there. Now, these were just a few of the misconceptions that my girls had, and the way I tackled them was, and having those small groups were really good because they were programming in class. I was essentially walking around entirely all the time, asking them why they were doing what they were doing. So it allowed me to just tap into that and figure out what was going on. Classes and objects being the same thing, that's a common misconception. My girls were no different. Init, oh my goodness. What is init? Why do we need to do that? Can we call the init constructor? Why is it called a constructor? Why can't it just be any other method? Why do we have to have methods? Why can't it just be called functions? Why are there so many things that mean different things but do the same thing? Oh my goodness, there was a lot. Self proved challenging. And yeah, so there was just a lot, but we worked through that. But also there were some students who wanted to go beyond, and these were some of the ways I extended them. We looked at the different types of variables, instance methods, class methods. We looked at exception handling, and some girls even wanted to maintain state, so we looked at how we would create persistence. All right, so just about at the end, this is how I set up my Canvas, and I'll give you a copy of the Prezzo as well. All the syllabus theory that they did, I made them do it at home. And we kept our classroom time entirely for programming because I didn't want them to do programming at home and be tempted with AI. I would rather them have that in the classroom so that I could see what they were struggling with, which would hopefully help me help them. They had really simple guidelines. They had instructions, and I gave them deliverables as to what they needed to produce in their teams. And each stage was a different, like roughly a week, week and a half, and we broke it up with theory along the way as well. All right? And so that's where we landed. And in terms of where to next, obviously I have to improve this a lot. There's a lot of work to do. But I'm also looking at potentially other popular culture mechanisms to reinvigorate how we teach programming in schools. So QR code, it's got the presentation, it's got the code samples, including 4 other programs that I didn't get to show you. It also has the self-paced lessons that my girls did over 4 or 5 weeks. Any questions, please come and chat. We're happy to get suggestions about what's worked for you, how to make it better. And thank you so much and have a lovely conference.